Hello, Jeff Zwerig here with Give and Take, where we look at the latest scientific issues, analyze them, and help equip you to be more confident in sharing the gospel. Today I'm joined by AJ Roberts, and with the release of Jurassic Park, we're going to look at an important question. Should we use techniques to change the genetics to fix diseases or maybe create new creatures? AJ, it's good to have you here today.
Thanks, Jeff. Good to be here.
So we got Jurassic World coming out, and I'm pretty sure the basic plot is we go in and do something with the genetics, create organisms, and now we have new dinosaurs. And this is kind of science fiction-y stuff, but are we even in the realm of this being a possibility?
There's some real challenges to actually recreate dinosaurs. One is we don't actually have copies of dinosaur DNA.
It's not in the amber in the blood?
No, so DNA
is
is really, really hard to extract from ancient bones or ancient fossils, right? The half-life's probably about 1.5 million years for DNA.
Right, and so we're well beyond that with dinosaurs. Okay, so we can't recreate the dinosaurs. But is this idea of being able to actually get in and take out sections of genetic code, put in new sections, I think that is something we're getting close to doing.
That is something we're getting close to doing, and not everyone's given up on the idea that we couldn't get something sort of dinosaur-like in the sense of we can sequence the genomes of birds and crocodiles, and we can sort of trace them back and look for what might have been common elements. Within the theory of evolution, what are the common elements? And so we might be able to construct something that was more dinosaur-like by saying, well, these are really ancient genes in crocodiles and birds.
That's fair. So that kind of lends the idea that we actually have some capacity to create new organisms, if you will, or at least take what was there and engineer something that's at least based on an old organism, if you will.
Yeah, something that's based on a current organism is how I would put it,
right.
but make it look a lot like what we've imagined these older organisms like dinosaurs might have looked
like. So what
like.
is this technology that we can use to do that?
Well, so the one that everybody's the most excited about that's super inexpensive, relatively speaking, and relatively easy to use is something called CRISPR-Cas9, and it was actually a protein that was functioning as part of an immune system for a bacterial organism.
Okay.
And so researchers in 2012 realized they could take that system and they could tweak it and actually target different organisms' DNA. So bacteria use it to target viral DNA that's infecting the bacteria, so it's part of the bacterial immune system, right? But if you take that system and you tweak the guide RNA, which is what's targeting the specific DNA of interest, in the case of the bacteria, a virus, in the case of researchers, a genome sequence of interest in your organism. You can actually hone that protein into a DNA target site, cut the DNA, insert new genetic information, or just change the genetic information that's there. And so it's a pretty powerful gene editing tool.
So that's remarkable. I mean, we're taking the genetic code, however long that genetic code is, going in and saying, all right, we're going to clip out this segment and put in a new segment that presumably does something.
That's right. Yeah.
So reality, you look at Jurassic Park, Jurassic World, that doesn't ever end well. I mean, it just doesn't work out well.
Yeah,
is this a good or a bad thing?
Yeah, that's a great question. We do these types of things because we're very interested in what we can do and what we can discover. And so in that sense, it's a good thing because it's part of the discovery process of scientists. But we want to be really careful sort of not to bring back animals, even if we could, that have gone extinct, because our ecosystems today are balanced for the organisms that are here. And if you reintroduce something that has no predator that's in existence, then you could actually upset entire ecological systems.
Well, we do that even accidentally, just by transporting stuff across state lines and across the oceans.
We change ecosystems accidentally and sometimes tragically, right?
So doing that, but there's got to be some good use to this, or we wouldn't be pursuing it. So what are some of the good things that flow out of that?
Sure. So the technology itself has lots of potential applications in medicine and in agriculture and in veterinary medicine. You can actually go in and target certain genes that might be associated with disease, or you could actually go in and target sequences that might be associated with viral infections that have been taken up by the organism's genome, and you can clip those sequences out, or you can repair a gene that's dysfunctional. And so, there's a little bit of a challenge to the specificity, making sure that you're hitting the target in the cell, the target that you want, and not off-site targets. And it's also a bit of a challenge to make sure you're hitting enough of the cell's DNA, that you're actually getting enough saturation of the system, if you will. The changes are in enough of the cells of an organism to actually make a difference.
So, I mean, it sounds like people have been doing this kind of research. I presume they've been working, maybe trying to target a specific disease or something like that. What sorts of things have they been able to accomplish?
That's right. So mostly
far?
things that have gone into humans already.
Okay.
That's mostly just the Chinese group at this point, and
Okay.
they've used it to target diseases like various cancers. They're targeting some eye diseases that
Okay.
are associated with either a network of genes or a single gene. So that's one of the challenges with this particular tool, is that if we know the disease is associated with a single gene, we can go in and target single genes much more easy than we can target things that are related to multiple genes.
Okay.
So cancer, eye diseases, some blood disorders like sickle cell anemia or beta thalassemia, these are diseases that are currently being targeted in humans.
So this sounds like stuff where you've got a human, they're kind of growing and thriving, they're alive and well, you're trying to go in and repair some.
Right.
I could imagine people want to push that a little harder.
Yeah, so let me back up and just say one thing. So some of the approaches are to take cells out of the human body, manipulate those cells with this technology, and then put the manipulated cells back in and let that be the treatment.
Right.
Others are using the CRISPR-Cas9 and actually going into adults and letting the CRISPR-Cas9 system do the work in the adult eye, or and so those are two different approaches with two different levels of risk, right? But then what you're suggesting is there can also be a manipulation of either the precursors to an embryo or the embryo itself. And when you start to monkey with organisms at that level, then you can actually introduce changes into the germline that would be part of subsequent generations of offspring.
So you're not just fixing diseases, you're actually changing the genetics, if you will.
Right, and we're far away from that in clinical applications, right? There are barriers, and some of those are moral and ethical barriers at this point, not just scientific barriers.
You know, I find this to be a fascinating technology because there is this chance to explore and grow and learn how things work. But this to me strikes me as a kind of very powerful tool. You got a very powerful tool. If you use it well, you can do great good. But if you do it poorly, you can do great damage. You know, and what I would encourage you to do is, I know AJ's written quite a bit about this CRISPR-Cas9, and go on to RTB's site, just search for CRISPR-Cas9, and you'll find a lot of resources to help prepare you, because what it's important for Christians to be involved in this conversation knowledgeably so that we can articulate the Christian worldview and help guide how this is all playing out. And that gives us a mechanism to be able to share the gospel, because the Christian worldview provides the mechanism that allows us to do this in a productive, healthy, and good way and avoid all the damages.